December 13th, 2025. Routine maintenance at Malaysia's €1 billion power hub becomes an emergency when a coal-handling crane collapses, trapping 5 workers in a tangle of steel. 2 are killed, 3 are rushed to hospital, and a vehicle at the scene mysteriously ignites. In a country where workplace deaths have surged almost 14% in 1 year, was this just a terrible accident, or the unmistakable sign of a deeper national crisis? The truth begins with a rescue operation where every minute exposes a new layer of unanswered questions. The collapse sent a shockwave through the Tanjung jetty, twisting steel into a maze that trapped 5 men where they worked. Alarms triggered, and within minutes Malakoff's emergency response team joined the first wave of firefighters from Pontian Baru and Pekan Nenas. The official record clocks the operation's start at 1 p.m. 15 responders split their focus, some racing to contain a small blaze flaring near a 4-wheel drive vehicle, others hauling cutting equipment toward the tangled wreckage. Every step was a calculation: where to cut, how to shore up beams threatening to shift, how to reach the men pinned beneath the crane's collapsed boom. Heat radiated from both the fire and the sun. Coal dust hung thick in the air, mixing with the smell of scorched rubber and diesel. The steel, still under tension, groaned as responders worked their way inward, aware that a single misstep could trigger a secondary collapse. Hydraulic cutters and saws bit through beams designed to withstand hundreds of tons. Progress was slow, measured in centimeters and minutes. By around 3 p.m., after hours of coordinated effort, 2 bodies were recovered from the heart of the wreckage. 3 others, alive but badly injured, were stabilized and rushed to Pontian Hospital. The operation stretched on for more than 4 hours, every responder knowing that the difference between life and death hung on their next move. What happened in those hours is logged in incident reports, but the questions they faced about speed, safety, and the unknown risks hidden in the steel remain unanswered in the public record. Official records set the operation's start at 1 p.m., but the timeline leaves gaps that investigators are still working to fill. The collapse and the emergency response blur together in the logs, alarms triggered, and teams mobilized. Yet the precise minute-by-minute sequence remains locked inside internal reports and CCTV hard drives. What is known is this: as the steel gave way, a 4-wheel drive vehicle parked near the jetty erupted in flames. The fire was contained during the rescue, but the cause remains under a separate active investigation by the Johor Fire and Rescue Department. Senior Fire Superintendent Muhammad Amaluddin Hisamudin confirms that his team is finalizing a report focused solely on the vehicle blaze, probing whether it was sparked by falling debris, a ruptured fuel line, or a shorted electrical system. The fire's timing, during the collapse according to the Johor Fire and Rescue Department, raises questions about the accident's complexity. Was the vehicle fire a symptom of a broader electrical failure? Or did the chaos of the collapse trigger a chain reaction no one anticipated? For now, the ignition point and its connection to the fatal crane failure remain unanswered. What is clear is that the investigation will require a careful review of control system logs, forensic fire analysis, and maintenance records to piece together what happened in those missing minutes. The search for answers continues. The logs and black boxes may hold the clues to a sequence that cost 2 young men their lives. On the Tanjung jetty, the coal-handling crane was the critical link between ocean and boiler. Every hour, hundreds of tons of Indonesian coal moved from ship holds to conveyor belts, feeding the plant's appetite for fuel. The crane's portal frame ran on rails above the water, its boom swinging out over cargo vessels and lowering a grab bucket into coal piles that could weigh more than a fully loaded city bus. In theory, the system was built for relentless work, with steel girders, heavy-duty drives, and control circuits designed to keep the coal moving without pause. But the environment fought back. Salt-laden air from the Johor Strait coated every exposed surface, seeping into welds and joints, while coal dust settled into crevices, holding moisture against the metal like a corrosive blanket. Over years, this constant assault weakened protective coatings and attacked the steel beneath. Routine maintenance meant climbing high above the jetty, surrounded by abrasive dust and humidity, trusting that every bolt, cable, and weld could withstand both the plant's demands and the unforgiving climate. In this setting, the crane was not just a machine. It was a lifeline under siege, where any overlooked defect could threaten the entire fuel chain. Every crane collapse leaves behind a trail of evidence, some visible in twisted steel, others buried in system logs or maintenance paperwork. For engineers, three broad pathways define the diagnostic map. The first is electrical. Insulation breakdown in humid, coal dust-laden cabinets can let current jump where it should not, igniting fires or triggering uncontrolled motion. Years of moisture and dust corrode relay contacts and cable sheaths, raising the risk of a short circuit, especially if safety interlocks are bypassed during maintenance. The second pathway is procedural. Lockout-tagout is supposed to isolate all energy sources before anyone climbs the structure. But global case studies show that under time pressure, steps get skipped. Motors are left live, brakes are released, or safety pins are pulled in the wrong order. Even a momentary lapse can let a machine move unexpectedly, turning routine work into disaster. The third is structural fatigue. Welds at boom to portal joints absorb millions of load cycles over years. Coal dust and salt air attack every exposed surface, thinning critical sections and hiding cracks until a sudden overload or maintenance-induced imbalance pushes steel past its limit. Investigators now face a checklist. Was it a hidden electrical fault, a procedural shortcut, or metal that simply gave up after too many years at the front lines? Each failure path leaves clues, and only a systematic probe can distinguish accident from inevitability. A real investigation starts with evidence, hard data, not speculation. Every control log from the crane's programmable logic controller must be downloaded, imaged, and preserved. These logs capture the last commands, interlock bypasses, and alarm signals in the seconds before the collapse. Next, investigators need a complete course of custody for every fractured steel specimen, bolt, and weld segment pulled from the wreckage. Each sample must be cataloged and tracked from recovery through testing. Metallurgical testing, including scanning electron microscopy, hardness profiles, and chemical analysis, should be performed on each sample to determine if fatigue, corrosion, or brittle fracture played a role. Non-destructive testing maps, including ultrasonic and magnetic particle scans of surviving structural members, are essential to reveal hidden cracks or section loss. All maintenance records, permit-to-work forms, and lockout-tagout checklists must be released, along with closed-circuit television footage and radio logs from the control room. These operational records show how the work was planned, authorized, and executed. Without this full catalog, programmable logic controller event logs, specimen test results, non-destructive testing defect maps, and documented custody, there can be no credible root cause report. Transparency demands that these artifacts be made public, not just summarized in press releases. Malaysia's Department of Occupational Safety and Health responded within hours of the Tanjung bin collapse, issuing 2 formal notices that froze activity at the jetty. All crane-related work was prohibited, and the accident site itself was sealed for forensic examination. Under the Occupational Safety and Health Act of 1994, employers found liable for safety violations face fines up to 500,000 ringgit, or 2 years imprisonment. These penalties are rarely tested at the upper limit, but the law sets a clear threshold for accountability. Deputy Prime Minister Datuk Seri Fadila Yusuf publicly demanded a thorough and transparent investigation, instructing the Department of Occupational Safety and Health, known as DOSH, the police, and technical agencies to cooperate fully, and promising consequences for any breach of safety protocols. The regulatory response at Tanjung is not just about this single accident. It reflects a system under scrutiny, where the balance between national infrastructure and worker safety is measured in both legal notices and lives lost. Families waited for news outside Pontian Hospital, hoping for answers that have yet to come. Muhammad Alfarid Ahmad and Muhammad Amaluddin Hisamudin were not direct employees of Malakoff, but subcontracted workers, young men whose contracts often meant less training, fewer protections, and little say in the safety systems around them. Under Malaysian law, their families may receive up to 266,000 ringgit in statutory compensation, but no sum replaces a son lost at 19 or 22. As flowers and prayers mark the site, the official findings from DOSH and the fire department remain unreleased. The causes, whether a missed inspection, a procedural gap, or a deeper flaw, are still locked inside forensic reports and internal records. For the families, for safety advocates, and for every worker who steps onto a high platform, the wait for truth is not over. Today, Malaysia's workplace death toll keeps rising. Over 38,000 accidents were reported last year alone. Modern engineering means nothing without a real safety culture and consistent enforcement. Until accountability is enforced at every level, billion-euro investments still cost human lives. The question is, how many more before that changes?